Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over Volume 2 of our 2020 AP Calculus AB multiple choice practice questions to help you get ready for the upcoming AP Calculus exam. Don't forget, we have 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of what we covered in this tutorial. And don't forget to visit our website at mathgotserved.com for tons of resources to help you do well on your AP exam. All right, let's take a look at question number 1. On question number 1, you're being assessed on how to find or evaluate the indefinite integral. So the formula that's going to help us evaluate the indefinite integral of x to the third over 6 dx is as follows. Our formula is, if you're integrating a multiple of a power, you're going to apply the power rule. But one thing you want to remember is anytime you're evaluating the integral and you have a constant multiple that you can factor out, always factor out the constant multiple so that it will make your integration process easier. All right, so notice I factored out that constant k. Now I'm going to apply the power rule to the integration of x to the n dx. Okay, so if I apply the power rule there, we're going to have the k that we factored out times x to the n plus 1 over n plus 1. All right, so anytime you're integrating a power, it's going to be x to that power plus 1 divided by that power plus 1. Since this is a definite integral, don't forget to add the c component right there. Alrighty? Okay. And this is known as the power rule with a constant multiple. So power rule with a constant multiple. Now, if you want to gain access to our entire collection of formulas that you need to know for the AP Calc exam, just visit our website at mathgotserved.com and you'll be able to gain access to that epic formula sheet that will help you see all the formulas you need to know for AP Calc AB. All right, so we're going to apply the formula that we just went over to our problem under consideration x to the third over 6 dx. All right, so the first thing we're going to do is we're going to factor out this denominator here. Notice I can rewrite it like this, 1 over 6 times x to the third dx. All right, it's easy to see what I'm about to do since I wrote it as a constant multiple as opposed to a denominator. All right, so let's go ahead and factor that out. So we have 1 over 6 times the integral of x to the third dx. Now I'm writing it like this as we talked about in the formula so I can easily see exactly what approach I'm using to evaluate the integral. Okay? So whenever possible, try to rewrite it in such a way that you can know the exact rule to apply. So this is a power, so we're going to be applying the power rule here. So we're going to have the 1 over 6 times, if we apply the power rule, it's going to be x to the power plus 1. The power was 3 before, so you add 1 to that, divided by the power plus 1. Okay? All right, now there's something missing. Do you see what's missing? Anytime you evaluate the indefinite integral, you always want to add that c component there. That's very important. All right, so plus c. Now we're going to go ahead and simplify our equation, make it look pretty. So we're going to have, this is going to become 1 over 6 times x to the fourth over 4 plus c. And then we'll multiply. That's going to give us x to the fourth over 24 plus c, and that, ladies and gentlemen, is the answer to question number 1. So let's see, question number 1, the answer is option letter C. So this is basically how you find the indefinite integral, by applying the power rule in a scenario where you have a constant multiple. All right, for question number 2, we're going to be learning how to find the equation of the tangent line, okay? We're going to be looking at the trigonometric function in this particular example. Question 2 reads, which of the following is an equation of the line tangent to the graph of y equals sine x at x equals 2 pi? Alrighty, so for this one, we're going to start off by writing down the formula that's going to guide our problem solving process. So the formula that we're going to be using is the formula for the equation of the tangent line. I'm going to call it EOT. All right. All right. So it's going to be y minus y1 equals m times x minus x1. Wait a minute. This is algebra, right? Yes, it is. This is the point slope form of the equation of a line. So you're going to be using the algebra here. But the calculus component involves the fact that you need a slope using only one point. The only way you can find a slope with a point, you need calculus. All right, so the m component is your slope. And that's going to be f prime evaluated at x1. Ladies and gentlemen, this guy right here, the derivative at a point, is known as your SOT, the slope of the tangent line. Another variation of this exact same equation using a and f of a notation is y minus f of a equals f prime of a times x minus a. In many calculus textbooks, this format is utilized. I like the one on top because it's familiar, it's easier to remember. Alrighty, so let's go ahead and get started. Let's write down all the things we need to write down the equation of the line and then put it into the formula, and we are good to go. Alright, so we need x1. x1 is where you are finding the equation of the tangent line at, and it is 2 pi. So x1 is 2 pi, and y1 is basically the output when you evaluate the function at the x1 value. So y1 is the function evaluated at 2 pi. So all we're going to do is plug in 2 pi into this trig function here, sine of 2 pi. Alright, so what is sine of 2 pi? We could use our unit circle, or you could also use your sine function to find the answer to that. We're going to use both of them. Just a nice little trig review here. So let's start by using the unit circle. All right, so let me draw my nice little unit circle here. Bam. Okay, so we're looking for 2 pi. 2 pi is 360 degrees. All right, so remember, unit circle means the radius is 1. All right, so this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi, full circle. All right, and then we need the coordinate here. The coordinate here is, what is the coordinate here? 1, 0. So you got to remember how the unit circle works, okay? Your y coordinate is your sine. All right, so y sin, don't forget. So the y coordinate is equal to sine theta. And your x coordinate is your cosine. So x coordinate is cosine theta. In this particular case, our theta is 2 pi. Okay, so we're looking for what is sine of 2 pi. So sine of 2 pi is the y coordinate, and as we can see, sine of 2 pi is 0. So in this particular case, is equal to 0. So y1 is equal to 0. Perfect. So we have x1 and y1. What else do we need? Let's see. We have x1 and y1. The last thing we need is m. Okay. So we're going to need some calculus for that. So m is y, the derivative evaluated at the x coordinate. Like that. All right. So this is a two-part process. Your SOT, slope of the tangent line, involves finding the slope anywhere, known as the derivative. So you need to find the derivative first. And then when you're done with that, you're going to evaluate your derivative at the specified x value, which is 2 pi in this particular case. All right, so moving right along, we're going to break it up and do it one at a time, okay? So let's do part one. So part one, we want to find, what are we trying to find? We want to find the derivative of the function. So the function itself is, what is the function? Sine x. So the derivative y prime, the derivative of sine is cosine. All right, cosine x. All right, so this is a slope of the tangent line at any x value. So let's fix the x value. Okay, let's find the slope of the tangent line at x equals 2 pi. So what we're going to do now for part 2 is we're going to evaluate the derivative at 2 pi, okay? All right, so we have y prime is cosine x. So y prime of 2 pi is cosine of 2 pi. All right, so earlier I indicated that I was going to show you the unit circle and the graph. I didn't show you the graph, so let's look at the graph. We're going to use the unit circle and the graph for both of them. All right, so the first one was sine of 2 pi. We found out that sine of 2 pi is 0. So let's look at the graph. So there's 0, pi over 2, pi, 3 pi over 2, and 2 pi. So there goes your sine functions, like an S. So like that. It's just a rough sketch. Oh man, it's terrible. So let's try that again. Goes through there, and then all the way over there. All right. Horrible looking sine function, but it's okay. All right, so this point right here shows you that the sine of 2 pi is 0. All right, and we know the trig function, the parent trig functions oscillate between 1 and -1. All right, so how about, so this agrees with what we said earlier here, that sine of 2 pi is 0, so that's good. So now we're looking for cosine of 2 pi. If you're using your unit circle, cosine is the x coordinate, so you can clearly see that cosine of 2 pi is 1. Alrighty, so that's basically what m is. M is 1. All right, now what if we wanted to use the graph that we generated to figure out what cosine of 2 pi is? So let's go ahead and refresh our memory on what a cosine function looks like. So it's like a cup starting from 1 center mean, center max. So this is the black one is a sine, and then this is a cosine. The red one is a cosine, okay? So right there. All right, so what does this show you? What does this show you? It shows us that cosine of 2 pi is 1, so our answer is correct. All right, so we have m. M was the ingredient that we needed calculus to find. Let's write down the other two ingredients that we need. x1 was given, and then we use x1 was what? What was x1? 2 pi. And then we needed to use some algebra and trig to figure out y1 when y1 was 0. All right, so we're going to put everything into this formula that we have right here. Let's rewrite it so we don't forget. Y minus y1 equals mx minus x1. So it's going to be y minus y1, y minus 0 equals m, which is 1 times x minus x1, which is 2 pi. And then if we want to make this pretty, we're going to have y equals x minus 2 pi as the answer to question number 2. All right, so the answer to question 2 is option letter C. So that's basically how you find the equation of a tangent line using calculus. Alrighty, let's go ahead and take a look at question number 3. Now, question number 3, we're being assessed on how to apply the chain rule in the differentiation process. All right, so we have to find the derivative of 2 times cosine root x quantity squared. All right, so let's go ahead and write down the formula that's going to guide our problem solving process. So we're going to be taking a look at what the chain rule formula is. So when do you apply the chain rule formula? When you are looking for the derivative of a composite function, basically a function inside a function. So let's say we have f composed with g of x and you want to find the derivative. So to find the derivative of this, all you do is find the derivative of the outer function evaluated at the inner function times the derivative of the inner function. All right? So remember dou d, derivative of the outer evaluated at the inner times the derivative of the inner. That's how you find your the derivative of composite functions or apply the chain rule. In this particular case, we have 3 functions composed with each other. We have the quadratic, trig, and radical functions. So in order to do this, since there are 3 functions composed as opposed to 2, we are going to be applying the chain rule twice. Okay, so let's look at the formula for that scenario. So what if you're finding the derivative of f composed with g composed with h of x? The same procedure applies. You just do it one step at a time. All right, no simultaneous differentiation and composition. So you differentiate the outer function f composed with the 2 inner functions g composed with h of x. So that's the first. And then times you differentiate the intermediate function, the middle function g evaluated at the innermost, times the derivative of the innermost function. All right, so this is chain rule applied on 3 functions. They are infinite. You can do it forever, okay? So just follow the same procedure. Now, let's go ahead and do it. In this particular example, I'm going to break it up. I'm going to do level this formula twice because this could get a little bit confusing, okay? All right, so we're looking for the derivative of 2 times cosine of root x quantity square. All right, so this 2 is getting on my nerves. Let me factor it out first. So okay, let me factor out a 2. So in differentiating and integrating, if you have a constant multiple, you always want to factor it out. So I'm just going to factor it out. Let me focus my attention on just cosine of the square root of x square. Now, when you factor out a constant multiple, please do not forget it. Okay, that's a mistake some students make. They factor it out and forget it. Now, just a side note, another way that this could be written is this could also be written as 2 cosine square root x. Okay, this is another way of writing power of trig functions. The power comes right before the trig function and then the inputs. All right, just FYI. Okay, so let's go ahead and get started with this. So to differentiate this function, we need to find what the outer and inner functions are. So for this particular example, the outer function is your quadratic. So let's call that f. Let's do that again. So this one right here is f of x. So f of x is x squared. And then the inner function is the composition of your trig and radical functions. We're going to call that g of x, okay? So g of x equals cosine root x. Okay, so let's go ahead and apply the chain rule. So what we're going to do now, I decompose it. I'm going to differentiate both of them, all right? If you look at the rule here, f and g are both differentiated. So let's differentiate both of them. F prime, if you differentiate x squared, if you apply the power rule, that is going to be 2x. And then here we have not just one, we have a composite function again. So g prime of x, we're just going to call it the derivative of cosine root x. Alrighty. Now, if we apply the chain rule here, is the derivative of the outer evaluated at the inner, so the inner is g. So we're going to plug g into the outer function and then multiply it by the derivative of the inner. Okay, so the derivative is going to be 2 instead of x, we'll replace that with cosine root x times the derivative of the inner. Okay, notice I'm breaking it down. I want to do it one at a time so that nobody gets confused here. All right, so there you have it. So now what we're going to do is we're going to focus our attention on this second derivative that resulted from differentiating g of x. Okay, so we're going to use the chain rule again. So we want to find the derivative of cosine root x. That's what we want to find. All right, so we're going to follow the same procedure. The outer function is f. That's your trig function. So f of x is cosine x. And then your inner function, g, is your radical function, root x. Okay, so g of x equals root x. Now we're going to go ahead and differentiate both of them. So f prime of x, the derivative of cosine, don't forget, is negative sine. And then if you differentiate g, the innermost function, the derivative of rad x is 1 over 2 root x. You can use the power rule here, but this is just a shortcut. Okay, so applying the chain rule, derivative of outer evaluated at the inner, so you take your inner function, plug it in here, times the derivative of the inner, right there. Okay, so the derivative of cosine root x is negative sine root x. That's the derivative of the outer evaluated at the inner times the derivative of the inner, 1 over 2 root x. Okay. All right, so what we're going to do now is just simply take what we just got and we're going to plug this answer that we have right here into this spot right here. Okay. I'm going to plug it in there. Let's go ahead and make the substitution. When we make the substitution, we are going to get 2 cosine root x, and then we have sine root x, and there's a minus in front, so toss that to the front. Okay, and then we have the times 1 over 2 root x. So 1 over 2 root x, so just if we multiply it here, it's going to be 2 root x. Okay, all right. So if you notice, initially the first step that we carried out was that we factored out a 2, right? We factored out this 2, so we're going to put it here. So we're going to multiply this by 2, so that changes this 2 right here to a 4. All right, so it changes that to a 4. And then if we just divide by 2, this 2 goes here 1, and then that becomes a 2. Okay? And that's basically our final answer. Our final answer is negative 2 cosine root x sine root x divided by root x. And if you look at the options, the answer to question number 3 is option letter B. All right, so this is an example of how you apply the chain rule twice in finding the derivative of 3 functions that are composed with each other. So on question number 4, we're going to be looking at how to integrate composite functions. In the previous example, number 3, we looked at how to differentiate composite functions using the chain rule. Now, how do you integrate situations like this? We have integral, the indefinite integral of x squared plus 2 over x to the third plus 6x minus 4. So let's go ahead and take a look at the formula that's going to guide our problem solving process. And the formula for integrating functions like this is known as the U Substitution integration technique. All right, so how do you know that you're supposed to use the U sub method here? Well, it is because if you differentiate the inner function of the composite, you end up with the real number multiple of the other function. All right, so if you have the integral of a composite function f of g of x dx, is going to be so f of g of x times the derivative of the inner function, or a multiple of it. This can be rewritten as the integral of f of u du. Okay, so the beauty of this U substitution method mainly is just to help you rewrite the integral in a more elegant form so it's easier to evaluate. Okay, all right, so to help you see the power of it, let's go ahead and apply to this problem. So first things first, I'm going to separate the composite function and the other function. So let's write down the composite function first, 1 over x to the third plus 6x minus 4 square. Okay, and then the other function is x squared plus 2, like that. All right, now the inner function from the composites, we're going to call that u. Okay, and then we're going to write that on the side right here. U is equal to x to the third plus 6x minus 4. And then the goal is to differentiate this and use algebraic manipulation to isolate x squared plus 2 dx from the differentiation of this equation. Okay, so let's differentiate. We have du equals 3x squared plus 6 dx. Now we want to get x squared plus 2. So in order to accomplish that, we're going to have to factor out 3 from this quantity right here. So if you factor out 3, we have x squared plus 2. Exactly, that's what we want. Okay, we want x squared plus 2 dx, but there's a 3 hanging out there, so we need to divide both sides by 3 to get rid of that 3 coefficient, and then we'll have a clean substitution. So du over 3 is x squared plus 2 dx. So this entire component right here will be replaced with du over 3. Now if we rewrite the entire integral using U substitution, it now becomes the integral of 1 over u squared du over 3. Okay, all right, so let's go ahead and make it look pretty. So we're going to just factor out this 1/3 right here. So we have 1/3 times the integral of 1 over u squared du. Now how do you integrate 1 over u squared? Well, we can reciprocate it and use the power rule. So we basically have to rewrite. Okay, so we rewrite this as u, if we reciprocate and negate the power, du. So let's apply the power rule here. 1/3 times the integral of u to the negative 2 is u to the power plus 1 over power plus 1 plus c. Okay, all right, so let's simplify that. If we simplify that, we're going to have, make it look pretty, 1/3 u to the negative 1 over negative 1 plus c. And then let's see what we have. All right, so simplifying further, we have, let's go ahead and write that down. Negative 1/3 times what? So this minus right here becomes a negative 1/3, and then you reciprocate this times 1 over u. So you can just have times 1 over u plus c. Alrighty. So we're not done yet. To finish this off, we have to resub. We know that u, the substitution we made right here, u is x to the third plus 6x minus 4. So we're going to resub to get our final answer. So we'll have negative 1/3 times 1 over u. So instead of writing u, we resub what u is, which is x to the third plus 6x minus 4 plus c. And the answer to question number 4 is option letter D. All right, so that's how you carry U substitution to integrate composite functions. Alrighty, let's take a look at question number 5. In question number 5, we're going to be assessed on how to find the concavity of functions. So 5 reads, the function f is given by f of x equals 3x to the third minus 1 half x to the fourth. On what intervals is f concave up? Alright, so let's write down the formula that's going to guide our problem solving process. So how do we know that a function is concave up? F of x is concave up on an interval AB if the second derivative is positive. There. Okay, so don't forget our fun charts to help us remember the pattern. So if you have f concave up, concave down, f prime increasing, decreasing, and then f double, positive, negative. So when given an algebraic function and you want to determine the concavity, just figure out where the second derivative is positive, and that will tell you where it's concave up. So in this case, we're looking for concave up. Alrighty, now and then if you think about the first derivative, it helps you. The first derivative basically helps you with the graph. Let's say we're given a graph, then we can use the first derivative to determine where it's concave up, basically where the function is increasing. Then you know that if you're given the graph of f prime, if f prime is increasing, then the graph is concave up. Okay, but we have an algebraic equation here, so we're going to be using f double prime and just looking for where it's positive. Okay, so let's go ahead and get started. We have the function f of x equals 3x to the third minus 1 half x to the fourth. So the first step is we want to find the second derivative of the function, and then we'll use it to find determine the signs around the critical values. Okay, all right, so we have this right here. Just gonna apply the power rule twice. So the first derivative, f prime of x, is 9x squared minus 4 over 2 is just 2x to the third power. All right, so we're going to go ahead and differentiate again, applying the power rule. So the second derivative is 18x minus 3 times 2, 6x squared. All right, so now what we're going to do next is we're going to find the critical values. Find the critical values. All right, so how do you find the critical values? These are basically where your second derivative is equal to 0 or does not exist. So let's say you're looking for the max and min of f. You look at the critical values of f prime, where f prime is 0 or d/n/e. But when you're looking for the concavity, you're going to use the critical values of the second derivative. Alrighty. So let's start with where the second derivative is equal to 0. So f double prime equal to 0. So you take this function right here, 18x minus 6x squared. So they're equal to 0. We're looking for the zeros of the second derivative. So factor out 6x, and then we're left with 3 minus x is equal to 0. And then using the zero product property, set both is equal to 0. So x equals 0 or x equals 3. Okay. So when it's f double prime non-existent, well, this is a polynomial function. It's smooth and continuous. We don't have any funny things happening here. So it's defined on the entire domain. Okay, so now we're going to go ahead and create our chart, our sign chart, to help us see the concavity of the function as it relates to the sign of the second derivative. Alrighty, so let's see our critical values. Let's go ahead and graph them. We have two. One of them is on 0, so we have one on 0, and we have the other on 3. All right, so we're gonna use the sign of f double prime. Sign of f double. F double is, let's use the factored state because it's easier to find the sign using the factored state. Is faster. 6x times 3 minus x. Okay, we're going to use the sign of f double prime to determine the concavity of f. Alrighty, so we have 3 intervals here to test. Interval 1, 2, 3. We're just focusing on where f double prime is positive. So this is first critical point, 0, and this is 3. Our test values, we're going to use -1 in the interval 1. We're going to use 1 for interval 2, and a number bigger than 3, we could use 4 for interval 3. Okay, so let's test it out. So for the first one, we're looking at f double prime of -1. So when you plug -1 here, all we care about is the sign, so we don't have to really work out the entire thing. So if you plug in -1 here, you have -1. Not -1, it's -6, but it's negative. And then when you plug in -1 here, it's 3 minus minus, which is positive. All right, and then minus times positive is negative. You can work it out, but you don't really need to work it out. You can just look at it, plug in the number, and figure out the sign. All right, so what does that tell us? The concavity of f is downwards, opening concavity. All right, let's move to the next interval 1. If you plug in 1 into 6x, you get a positive number. If you plug in 1 into 3 minus x, you get 2, which is positive. So this is a positive. Sign for the second derivative, which means that the function is concave up. And then for 4, if you plug in 4 into 6x, what is 6 times 4 is 24, which is positive. And then if you plug in 4 into 3 minus x, 3 minus 4 is -1, which is negative. So if you multiply the signs, you have minus. So that tells us here it's concave down on interval 3. So we have only one interval where the function is concave up, and that is from 0 to 3. Okay, so let's go ahead and write it down. F of x is concave up. Yeah, it's concave up on 0 to 3. Why? Let's just put the justification there because the second derivative is positive on that interval. All right, so that's basically how you find the concavity of a function in algebraic form. Answer to number 5 is option letter C. All right, now it's your turn to do some practice problems. We have 5 practice problems for you to try out. So go ahead and pause this video presentation at this time and try out these problems. When you are done, click on the play button and we are going to show you what the answers are. Alrighty, welcome back. So hopefully you had a chance to try the problems. Let's take a look at what the answers are. For question number 1, the answer is option letter D. For question number 2, the answer is option letter A. For question number 3, the answer is option letter C. For number 4, the answer is option letter C. And for number 5, the answer is option letter A. So how well did you do out of 5? Let us know in the comment section below what you scored. And if you have any questions, comments about these practice problems or the problems we went over in general, just put it in the comment section and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other tutorials such as this. Um, Questions or comments, just put it in the comment section below, and do not forget to visit our website for our epic formula sheet and other valuable resources to help you pass the AP Calc exam. Thanks again for watching, and have a wonderful day. Goodbye.